Well, good evening, everyone, and welcome to Lowell Observatory's Comet NEOWISE live stream. I am Jeff Hall. I'm an astronomer and the director of the observatory. Joining me tonight on screen is Dr. Dave Schleicher. He's a professional astronomer here on the research faculty at Lowell and an expert on all things cometary. We also have with us off screen tonight Sarah Bircher, our outreach manager. Up at the Giovale Open Deck Observatory. That's my virtual background here is our new public observatory. And Danielle Adams and Heather Craig of our communications team are keeping everything streaming along tonight and will be helping feed us some questions. Now, you also see on the screen a small image of Comet NEOWISE. We took that last night, or Sarah took it last night, up at the Giovale Open Deck Observatory because we had a suspicion the weather tonight might not be very cooperative, and indeed that's the case. July and August in Arizona, the North American monsoon brings our daily thunderstorms to the region. We always really need the moisture, but it kind of puts a stop to a lot of observing. And in fact, many of the professional research facilities in Arizona have planned shutdowns. Right now, our Lowell Discovery Telescope, the Navy Precision Optical Interferometer, even the telescopes down at Kitt Peak, we just plan to take them offline in July for maintenance. You've got to do that anyway, and you may as well do it when you know the weather's not really going to be very cooperative. But the good news is we have a lot of really cool images of the comet for you tonight. And actually, those will be more striking than what you would see with a live view. As Dave will discuss, the comet is now getting fainter. And with a live view, it's actually not as detailed and as impressive as some of the images will show you. So what we're going to do tonight, I'm going to turn it over to Dave, who has a presentation, all things about the comet, the circumstances of this apparition, how you can observe it. And then after that, we will take a few questions as we go along, and then at the end, we'll have a final Q&A as well. So thanks again for joining us, and at this point, I'm going to turn it over to Dave. Take it away, Dave.
Thank you very much, Jeff. Happy to be here this evening, although very disappointed with the weather conditions. I'm going to bring up the presentation, and I think this should be fine. So I've had difficulty deciding on a title for this, but one of the key aspects is that Comet NEOWISE has been a very elusive to observe. So I decided that's as good a title as any for the moment. So I'm going to break this up into a couple of pieces. We're going to spend a few minutes on giving background regarding what comets are, why we care about them, then switch gears and talk specifically about Comet NEOWISE, both what we know from before as well as what's going on at the moment and how to go and find it yourself. And then at the end, talk very briefly about how to do photography of the comet before showing a number of images we've accumulated from both everywhere from my backyard to people around the world. So I need to start off with this cartoon by, as you well know, Charles Schulz and Peanuts. Give you a moment to read it. I'm always impressed by the constancy of the stars. It gives me a feeling of security to look up and know that the star I see will always be there and will. And of course, Snoopy was seeing what's commonly known as a shooting star or meteor. Comets are not meteors. Comets hang around much longer in the sky. NEOWISE has been around for easily observable for the last couple of weeks. So just to clarify, meteors are little bits of dust or dirt that hit the upper atmosphere of the Earth and burn up in a few seconds' time, while comets are millions of miles away, and while they're moving fast, they aren't moving anywhere near that fast as seen from Earth. So those who are old enough, and that would be sort of around 30 years old or older, will remember Comet Hale-Bopp in 1997. And this was truly the comet of the decade back in the 90s. And in particular, the striking thing are its two tails. And if I step ahead, I'll note that the tails themselves, the blue tail that you see here, is an ion tail. It's plasma, in particular carbon monoxide. And then the whitish, slightly pinkish tail, much broader generally, is a dust tail. And all of this material is coming from a quite small area near this, down here in the center. This region near the center, the coma or head of the comet, is the part that I study normally. Most comets are not nearly as bright as NEOWISE. That doesn't put me out of a job when we don't get bright ones. Instead, that's typically all you get is the coma of the comet. And my own observations are to determine things like the composition of the ices and physical properties like how fast does the comet spin. And then finally, where everything's really coming from is the nucleus, which in this case is so small that you just can't see it. It's completely overwhelmed by the light of the coma. And the nucleus is made up of dirt and ice. And the ice is mostly water ice, but also dry ice, frozen carbon monoxide. And the size of the nucleus might be anywhere from 1 kilometer to 30 to 50 kilometers. In the case of Hale-Bopp, it was at the high end, 50 kilometers or 30 miles in diameter. And the tail literally stretched tens of millions of miles out. I will also note now, because I'll forget otherwise, is that the tail always points away from the sun. So when the comet was approaching the sun, the tail was streaming behind it like you would expect. But now, as in the case of NEOWISE, it is moving away from the sun, the tail is actually leading the comet, not trailing the comet. So I wanted to show just 2 images of the nuclei of a couple of comets. One was Halley's Comet, and I note this because this was the very first comet to be imaged up close by a spacecraft. And what you can see here is the nucleus runs along here, comes up about there, comes back around, and is quite dark. The sun is up in this direction, beaming down on it. Sunlight is heating up ice on the surface. The ice is vaporizing. As it turns to a gas, it rushes off in these jets of material. And the reason that happens is because there's almost no gravity because the comet is so small. So there's nothing to hold the gas down. And then any dust that was embedded in the ice originally literally goes with the flow. So these are streams of both dust and gas coming off. Now, this is not a very spectacular image, mainly because technology back in the mid-'80s was not nearly as good as what we now have. Finally, this was about 10 miles in length, and to scale, the San Francisco peaks are the peaks just north of Flagstaff, and this is to scale. This is the most recent comet to have been imaged. European Space Agency had another spacecraft to a comet, Rosetta, 5 years ago. And this is a really odd shaped one. It has basically what we believe are two comets that ran into one another, stuck together, and that's why it has this weird shape, which was called the rubber ducky back at the time that it was discovered. And again, you can see jets of material coming off from various locations. So why are we studying comets? Historically, it's very simple. Comets were omens of doom. You get a good bright comet coming along every 6 to 10 years or so, and inevitably something bad happened. Why? Because something bad happened every year in history. And so if you saw a comet, you could blame the comet, or at least argue that the comet was foreshadowing that this terrible thing was going to happen. The current, more scientific explanation, of course, is a lot wordier. Primordial material from the era of solar system formation. This stuff is left over from the time that the sun and then the planets formed, and it has been preserved in the outer solar system in literal deep freeze. The comets that formed probably in the region of Saturn, Uranus, and Neptune, those who survived and didn't collide with either a planet or the sun along the way got pushed out to distances beyond Neptune and Pluto into what's known as the Kuiper Belt, or even much further into a cloud of materials surrounding the solar system called the Oort cloud, and that extends to a quarter of the way to the next nearest star, or over a light year away from us. Those objects are sitting out there for millions. Well, their orbital time takes millions of years, but occasionally one of them will get gravitationally perturbed, head into the inner solar system, and if we're lucky, we're here at the time that they come by. And finally, I note that comets are a source of water on Earth, or as well as on Mars. In fact, there's a bit of comet in every one of you out here viewing this. It's estimated that about 10 to 20% of the water on Earth, and therefore the same percentage in each one of you, came from comets very early in the solar system, 3-4 billion years ago. But also, comets have been the source of mass extinctions. I'm sure you've all heard of that the dinosaurs were wiped out by an asteroid impact. In fact, we don't know whether it was an asteroid or a comet, and there's arguments to be made on either side. When you're 10 miles in size and you hit the Earth, it doesn't much matter whether you're made up of ice or dirt. Terrible things happen. I'm going to take a quick break here and see whether there are any questions at this point. Jeff?
Yeah, thanks, Dave. I see we've got a couple of, for those of you, all of our viewers, we have a couple of our staff members on the chat feed. I'm watching it go by right now. So I see Kevin White and Ariel Daniel, Claire Gibson, and Hannah Zigo are all online. Those are all Lowell Observatory staff, and they've kind of caught a lot of the questions. There was one question that came in, Dave, that was asking why they called it NEOWISE and what sort of makes it a comet. You'll probably cover that a little later in the show.
I will.
Okay. So yes, that's all the questions we have at the moment. So perhaps we can continue with the next part of your presentation.
Very good. NEOWISE. So Comet NEOWISE was discovered in late March. On the title slide, you saw it listed as having the designation 2020 F3. 2020 was the fact that was discovered in this year. The F3 meant it was the third comet to be discovered in the second half of March. Don't ask where these conventions come from, but they basically letter them for every half month. The name NEOWISE comes from the fact that comets are always named for who or what discovers them. And in this case, it was NASA's NEOWISE spacecraft observatory that made the discovery. NEOWISE, if I can remember, stands for Near Earth Object, Wide Field Infrared Survey Explorer. This was a mission originally called WISE, and then when that original mission ended, they came up with enough funding to keep things running and tacked on NEO to distinguish which part of the mission they were in. So when the comet was discovered, and remember this was from a satellite, so it didn't much care where in the sky it was, but it was very far south as seen from Earth. And so we made no observations of it inbound from Lowell. Other people were making some observations, but for the most part, it was a very faint object. Then it came in very close to the sun. In fact, it came in to inside of Mercury's orbit, which really did a good job of cooking the comet and vaporizing a lot of ice and therefore releasing a large amount of dust, forming the beautiful tail that we end up seeing. But when it started coming out from behind the sun, it was in the northeast in the dawn sky. And I am notorious for not wanting to be up at dawn unless it's because I was observing all night long. So I, in fact, did not see it until just a week ago, where it is now in the northwest and receding from the sun and getting very faint. One of the key aspects is the distance from the sun determines how much heat is coming from the sun that is vaporizing the comet. And so as it recedes from the sun, it's just not getting as much energy from the sun, not as much vaporization is going on, and that's why the comet is getting fainter. So even though this morning was closest approach to Earth, what matters much more is the distance from the sun, and that is just not going the right way to make it visible. The orbit, as I said, comes inside of the orbit of Mercury, but goes out to about 10 times the distance to Pluto. And that means that it's in a very elongated orbit, and it takes, well, it took 4,800 years from when it was last in by the sun to the current time. So the current status, and I'm going to show you a chart right after this text slide, but basically you're going to be wanting to face northwest and below and to the left of the bowl of the Big Dipper. And the Big Dipper is going to be sitting up almost directly to the northwest, about halfway up the sky. So that gives you a little bit of information where to go. Every night, everything that you see over in the west is setting minute by minute, hour by hour. Things drop in the sky about 10 degrees every hour. And at this point, the comet will be very low by about 2.5 hours after sunset. From night to night, NEOWISE is moving about 2 degrees each day, each night towards the upper left, and I'll show you that as well. But I want to emphasize the fact that by next week, the moon will be really coming into view. Right now it's a crescent moon, but that will be moving towards first quarter. That will be lighting up the sky enough to make it even harder to see the comet. All things considered, binoculars would be a very wise choice to have with you for looking at the comet. So in this chart, well, no, here's north, here's west. So we're facing northwest. If you look halfway up the sky, here is the Dipper. Most of you know that you can use these two stars in the bowl of the Dipper as pointers to run you up to the North Star, Polaris. And it's always a great thing to use to get the directions. But coincidentally, tonight, tomorrow night, the next night, NEOWISE is right here in the opposite direction from the pointer stars and about half the distance. So whatever this distance appears to be when you go outside and you look at this, you want to go about half that way down here for NEOWISE. This is the location tonight. Each night it will be moving up another, as I said, about 2 degrees, like so. And a week ago, we were looking at right down in here. So that's the path it's been following. A break again.
Okay.
I do see a question about whether one can see it without binoculars. I did last night between the clouds. At the moment, it is about the brightness of most of the stars in the Little Dipper. A week ago, it's about the same brightness as the stars in the Big Dipper, 2nd magnitude, but now it's down to about 4th magnitude, or about a factor of 5 or 6 fainter than just a week ago. So you can see it, and in fact, if you know about averted vision, where you don't look quite at the object, but a little off to the side, with averted vision, I had no trouble still seeing the tail. Okay, Jeff?
Yeah, we got several questions, so I'll just give a quick update for all the viewers. We've got a lot of questions coming in on the chat because we've got about 2,000 viewers online. So those of you watching the chat feed, if you see answers from Kevin White and Hannah Zigo and Claire Gibson, they are all Lowell staff members and they know exactly what they're talking about. So they're giving you really good information. We've also got some pretty good questions, Dave, that have come in on the feed. I do want to remind everybody right now, we are socked in with rain and thunderstorms in Flagstaff. So we do not have, cannot have a live feed up. We do have our outreach manager, Sarah Bircher, up at the Giovale Open Deck Observatory, but I very much doubt that the conditions are going to permit us to open it. So yeah, there are a number of questions on the feed that we'll just run through. This is actually a good question from some guy. So how often does a comet visible to the naked eye come to the inner solar system and subsequently Earth?
Excellent question. Partly depends on how faint or bright you can see. Those that are just barely detectable, we typically have one every 2 or 3 years. Many of these are the comets that are in short orbits that go out near Jupiter and then in near the orbit of Mars or Earth, or even closer in towards Venus. But just in the last 8 years, there were 5 of those that got up bright enough that you could just barely detect by eye. On the other hand, none of these short period comets that come around every 5 to 10 years ever gets real bright. And so you have to wait for these comets coming in from the Oort cloud. And the problem is you have no idea when they're coming until somebody discovers it, and then you hope that the comet will be heading in close enough or the comet is bright enough that we'll be able to see it. The big bright ones, like Hale-Bopp, there have been none that bright since Hale-Bopp. This is about the third or fourth one at sort of this brightness, where it's, if you looked at the right time, it was very obvious, but it still was not something that was brighter than Venus, for instance.
Okay, very good. And perhaps slightly related to that question is, when is the next known great comet going to be visible? Is it Halley or another one?
Well, the next one that we know will be coming around is, in fact, Halley's comet,
yeah.
Comet Halley, in 2061. It is just about at its furthest distance since its last time around in 1986. The key thing that makes Halley special is that first, it was the first one that was predicted to come back, and the person who did figure that out was Edmund Halley, which is how he got his name attached to it. And it is also physically the largest one that has an orbit that is less than 100 years. So you get it back every 76 years or so. For anything else brighter, we have no clue until somebody goes and discovers it coming in. We didn't know about this one until, as I said, in March. There were a couple of others that we thought might be brighter this year, and one of them partially disintegrated before it arrived. And we thought, well, I guess that's not going to be the great comet of 2020.
Yep. Okay. So, right. So Halley is back in 2061, you said?
2061.
Yep.
I'm embarrassed to say how old I will have to be able to make it till then.
Right.
I have my doubts.
Okay, so we do have some other questions. Some of the questions in the chat feed here, I see our staff are answering. Here's a really good one, though. You might be addressing this a little later in the talk, though. Question from William Bailey. Have you been able to obtain spectroscopic data on Comet NEOWISE, and how does its composition compare with other long period comets?
I was scheduled for one of the other Lowell telescopes just this week. Starting Monday night was the first night that it was high enough in the sky that I was going to be able to make observations. And we have been clouded out every night for that.
Yep.
I will be trying again this weekend. And if I'm not successful, we'll have to wait for a couple of weeks till the moon no longer becomes an issue. But I'll then try again in the second week of August. And it will be quite faint compared to this, but it will still be bright compared to most of the comets I have to, for most of my studies. I have not heard any information from anyone else who does spectroscopic observations of having any results yet. I think it's just very difficult to point telescopes that low in the sky.
Yeah, it is quite low. Okay, we'll do one more and then go back to your presentation. Question from Wesley Cole. Would it be possible for a comet to come as close as some meteors have without being detected, or the melting coma will always give them away from a safe distance?
There are so many search telescopes out there looking in different directions. Nothing's going to get in that close without detection.
Right. Okay, well, let's go back to your presentation.
So we're switching to the photography portion of this, and I have only this one slide regarding how to do it, but I know various people do want to try taking pictures of it, and hopefully they're in locations a lot clearer than where we are tonight. A camera, tripod, pick your favorite lens, I tend to use a telephoto lens from, say, a 70 to 200 millimeter, but it's your choice on how much of the sky you want, how much you want to blow up the comet, expand the comet. Blow up has a different connotation. You want a fast ISO setting, especially now that the comet is getting fainter, 1600, 3200, for instance. And you want to be in manual mode with the F ratio essentially wide open. To get as much as possible, you'd like a long exposure, but everything you're looking at in the sky is setting as the Earth rotates. And so a 200 millimeter lens, you will start to see star trails and the comet trail in just a bit over 4 seconds. For a more of wider angle view, such as a 70 millimeter, you can go about 10 seconds before you start seeing the trails. A particular issue that always comes back to haunt me is having your focus at infinity. The comet is essentially at infinity, but most autofocus systems on cameras these days do not work at such low light conditions. And so it will just keep bouncing back and forth trying to find the focus, and that's not a good way to get anything useful. And it used to be that you could just turn the focus ring on a camera, a lens, to one end, and that would be infinity. But they now design cameras so that that's beyond infinity, whatever that means. And so you still end up with all your stars and the comet looking like donuts. So I recommend get it focused to infinity during the day while there's daylight and lock that down, mark it, check this during the evening so that you're not disappointed with what you get. So with that as a how-to guide, here is a shot that I took late last week from my front yard. A few clouds going across. I was pretty happy with this, all things considered. And that was an exposure of about 5 seconds. Here is from the night before last, and that's basically the best shot I've been able to get. I have not done very much in the way of enhancing these images. I just don't have those tools set up. But you can see both the dust tail very prominently here, as well as the blue ion tail. And the head of the comet has a turquoise or cyan color, and this is caused by the emission of diatomic carbon molecules who emit in the blue-green. And so this is a very characteristic aspect. Here is a shot from Joe Lama. He's one of the Lowell astronomers. And he took this shot from the Grand Canyon. One of our advisory board members for the observatory, Eric Johnson, sent this image in. Bill Peters is a consultant for our new visitor center that we are getting ready to start construction for. He lives in Alberta, Canada, and sent me this shot with the northern lights. This was actually on the astronomy photo of the day website, APOD. Has marvelous images updated daily. Here is one from Charlie White, which people associated with Lowell might know because Charlie is the son of Nat White, who was a longtime astronomer here. And he's been working on the Big Island of Hawaii. A view that I know you'll see later again of the Giovale Open Deck Observatory with Comet overhead. This was taken either last week, Friday or Saturday, the last of the clear nights that we had. This is one of the most spectacular ones I've seen that really focused on just the comet. And you can see all of these streamers in the dust tail. And this is primarily due to the dust being emitted from the nucleus, probably is coming off for a bit. And then as the comet rotates, that part of the comet no longer is getting sunshine. It shuts down, doesn't put out as much material. And then with each rotation, you get another burst of material coming out. I should not have to say where this is from. But if anybody doesn't recognize it, this is Stonehenge. This is one of my very favorite images. Never been to this location, but I know other people who have. And finally, this one just came out about a day ago. And that's just a very nice composition. I'm a photographer in my non-existent spare time, so I always appreciate interesting images. And with that, I'll simply note that the NEOWISE show is not yet over, but if you're going to look at it and you haven't seen it yet, you better get out and do it real soon, because by early next week, there's going to be a lot of competition from all that moonlight. And in another couple of weeks, it will be another factor of 20 to 50 fainter than it is now. So the show is almost over, but there's still a bit left. Jeff.
Okay, thanks a lot, Dave. If you unshare your screen now, and we will wrap up the live stream here. We do have a few more questions on the chat. I see our staff are continuing to answer in the main chat on the YouTube feed, but there are a couple of good ones here that I know you can answer. Here's an interesting one from Kimberly Calls, sort of a couple of questions that do relate to the lifetime of the comet. So she asks, if it's going so fast, why doesn't it burn up? Is it burning away more each time it gets close to the sun? And will it eventually burn up? It's a good question.
So of course, all of this is happening in a vacuum, so there's no friction going on. It's happily moving around its orbit. Every time around, it loses some more material. Given that this one came inside Mercury's orbit, it probably lost, and this is an estimate, probably about 30 meters worth of ice on some parts of the comet. Think of that as 60, 80 feet worth. So a fair bit has gone away. The size of the comet is about 3 miles in diameter. So this one cannot keep coming in that close to the sun all of that often before there's nothing left.
Yeah, and No, yeah, right, and yeah, and eventually, yeah, it's finite. I see Danielle is scrolling through some views of the comets as we answer these final questions. These are different views taken by various Lowell staff members. So let's see. Jessica Blakely asks, oh, another good question here. Will the tail look to this same to the naked eye or in binoculars the same as in the pictures we see?
Basically, yes. It's the time exposure was just to get enough light to be able to make a good image. But as I said, I was able to see the tail with averted vision, where you're looking just a little off and sort of thinking about this spot, but looking there. So I could do that from my front yard in Flagstaff. So you get a decent dark location, that makes it much easier. The binoculars, though, will make it just so much more dramatic.
Yeah.
And in fact, for most binoculars, it will be about the size of the field that you get with your binoculars.
Yeah, the first time I went out, and first time I caught it in the binoculars, and it just filled the view, and it was pretty breathtaking. It really does make you just so let's see. Oh, here's a good one. Yeah, Lisa Davis asks, what would happen if the comet hit Earth? And I think the short answer is a big mess.
So the comet that hit, or the comet or asteroid that wiped out the dinosaurs and changed evolution of everything 66 million years ago, was only 10 miles in size. This one is about 3 miles in size, which is, well, it's a third, but then everything is cubed for the volume. So this would, half of the continent that got hit would be pretty much done.
Toast. Yep. Yeah, it would be pretty nasty. Here's one I know you can answer from Russell Frizzell. Dr. Schleicher mentioned comets are made of ice and dust, and he wants to know what's in the dust. What's it made of?
I think of it as just, it's dirt. It has the material that comes off. Much of it is sort of the size of talcum powder, very fine material. But the problem is, I'm not a chemist and I'm not a geologist. Mm-hmm. So I think I'm going to sort of stop there. Okay.
Yeah, and question, does Lowell do anything for the MPC, which for everybody who doesn't know, the acronym is Minor Planet Center?
A lot of observations from Lowell Observatory get submitted to the MPC. The MPC collects data, particularly for where is an object as a function of time. So as we're trying to learn the orbit of a new comet, data from both Lowell and other locations go in and are used for actually calculating the orbital motion of the object.
Yeah, okay. And there's one more question on the chat at the moment. So we'll ask our viewers if there's still any further questions you want to ask before we wrap up here. Question from William Bailey: what causes the formation of antitails on comets?
Antitails are just, it's a perspective effect. So if I have a tail, if here's the nucleus and I have a tail coming out this way, that's what you're going to see. But if the tail is coming out sort of like this, you saw the dust tails being curved. And sometimes you'll get the curved tail coming back around and therefore appear to be coming out this side rather than out the direction that's away from the sun. And it's just the fact that the tail is almost directly away from you, and the end of the tail happens to be in projection sticking out the front side.
Yeah. Okay. So we'll wrap up here with just a few final thoughts. I certainly appreciated your comments. There were some questions going by about the significance and the importance and why the comets captured so much attention. I think these transient sights in the sky are always quite interesting. You pointed out that these have been omens, of doom since long ago, and that still persists in our language. We study astronomy, and that comes from the Greek and Latin words aster and astrum. And even today, when something terrible happens, we call it a disaster, which is literally a bad star. And so these things have been very significant to people for a long time. But then scientifically, I know you were sending some information off to Discovery earlier and pointing out this is an ancient object. Sort of a remnant of the earliest solar system. It's like looking through a glass darkly, billions of years.
So these days you start, and we've had the missions going out to Pluto and out to one of the Kuiper Belt objects. You can learn a lot in that quick flyby. But studying the composition of lots of these objects, there's no way to do it with spacecraft. Well, why not just wait for the comet to come to us? And by definition, these comets can't last very long, like one of the other questions. It loses material each time around. So when we're seeing this is a rare opportunity, but it's of an object that is billions of years old, kept in deep freeze, brings the material into us, and then conveniently lets the material off the surface out where you can study it. It's a great thing.
Yep. It's a great
and the good news is that there are dozens of these discovered every year that are bright enough to do those type of studies. So we here have measured well over 200 comets in terms of their composition.
Yeah.
And that would not be possible if I had to wait for the ones that were bright enough to see by eye.
Well, really, after waiting, 10 or 20,000 years, I'm going to be sick of waiting for these things. So it's good when they come by. We did have a couple of other questions come in. One viewer asked, let's see, this is from Bernie D. Wanted to know, when we're seeing these tails, how big are the particles we're looking at in the tails?
Much of that material is really, as I said, talcum powder in size. A micron, a few microns, 10 microns. There are some bigger particles in the mix. And actually, the shape of the tail can be used to determine the size of the particles, because the tail, the dust is pushed out away from the sun by sunlight. Well, how fast that happens depends how small or large the particles are. So the shape of tails actually tells you things like particle sizes.
Yep. Okay. And then last question, and then we'll sign off. And this is sort of going back to the question of how old this thing is. Even if it's a primordial object and it's 4 billion years old, the question is, how long has it actually been a comet? And that would probably relate to when it got kicked out of the Oort cloud, however that happened.
Yeah. So I would guess that it got its kick out of the Oort cloud 5 to 10 million years ago, because it takes several million years just to get into the inner solar system. Probably then went a little too close to Jupiter, which changed its orbit and changed it so that it never went back out all the way again. Now that it's in a smaller orbit, coming around every few thousand years, now it's only going to last, well, if it stays in this orbit, maybe another dozen to 100 times before there's nothing left.
Yep. Okay, and with that, I'd just like to thank everybody for joining us. NEOWISE will be back, as we said earlier, in 6,500 years. So everybody just watch our website, come back and join us in 8520, and we will have Dr. Schleicher for for an analysis of how the comet has changed on its next orbit. Until then,
or my mummy.
Yeah, until then, we hope you have clearer skies than we do tonight. Go out and enjoy the sight. As Dave pointed out, at this point, it is going to start fading pretty darn fast because it's getting farther from the sun and farther from the Earth. And that's a double whammy as far as how bright it's going to appear. So maybe over the next several days to week, with the naked eye and with binoculars, you can still enjoy this once-in-a-lifetime sight. We hope you've enjoyed the live stream. Please check our website and our YouTube feed where we offer several live streams a week, and hope to see many of you here to join us for the other ones. Until then, from all of us here at Lowell Observatory, as always, stay safe, stay healthy, stay well in these weird times, and have a great night.
Good night.